Hello everyone, it's June the 3rd, the late night one. I had a long day. Also had a few meetings today. Mainly to handle Firebase. We're trying to figure out how to connect an app with Firebase emulator, and also how to run tests, unit tests in Firebase with emulator. And I think the final conclusion is it's not possible to run the app in the test environment. Not in test. I'm going to rephrase it. It's not possible to use Jest to run the app and also connect to the emulator. It's not possible. At least we didn't find any way to do it. The only way that we eventually settle down for is we're going to separate the front end testing and the back end testing in the app. The front end testing will be purely for how the app is going to look like, and the backend testing will be for everything Firebase related. Because to test the backend, we can use something called Firebase admin, and when we use that, we don't have to go through any of the app part. So it's just direct communication with Firebase. So by separating these two, it is possible to run the test that we want to write. So that took about a whole day actually to figure this out. I mean, and in retrospect, this seems very obvious, right? This is the correct way to do. Front end is front end, back end is a back end. The original plan to test has the two mixed together, and it's never going to work. I mean, I should take it back. It does work in integration test, and I think we can use Detox to do integration test on this. However, we are not at the integration test level yet. We still just want to write a unit test at the current stage. So separation of concern of these two, the front and back end, I think it's a necessity, something that we should have thought about to begin with. Anyway, we were working on that for a whole day, and then had like an hour-long meeting, trying to get the team to understand where we at. So it took a while. Anyway, we are going to do the LeetCode today, and also take a look at what we have. Maximum area of a piece of cake after horizontal and vertical cuts. Given a rectangular cake with height h and a width w and two arrays of integers, horizontal cuts and the vertical cuts, where horizontal cuts I is the distance from the top of the rectangular cake to the ith horizontal cut, and similarly a vertical cut j is the distance from the left of the rectangular cut cake to the jth cut. Determine the maximum area of a piece of cake after cut at each horizontal and vertical position provided in the two arrays. Since the answer can be huge number, return them all in a modular. Okay, so horizontal we have, no, the height is 5, width is 4, when I cut at 1, 2, and 4, I cut at 1 and 3, and return is 4. After cut a cake, the green is the maximum. And after cut this, we have two maximum. The green and yellow both are maximum. And this one gives us 9. Yeah, because we only cut once, two times. So okay. Height, a large value. Horizontal cuts 10 to the 5th. And each one will be, is guaranteed that all elements in this are distinct and all elements in this are distinct. It's an interesting question. Let's think about it. I mean, after we do the let's say we're gonna say vertical cuts first, just arbitrarily, right? And after vertical cuts, we already know which stripe has, after vertical cuts, we know which one is the biggest. And then given the horizontal cuts, with each horizontal cut, we are able to, get the vertical cuts, right? So we know the distance between, we know the width, right? We know the width just by looking at here. So that's a 1. It's going to be, not vertical, because be a 2, and it's going to be a 1. So we know. And then we do horizontal cuts. And each horizontal cut will give us the value, because the horizontal cuts give us the height. And then we know the value, know each one of them, and then we just run through, which means, this is like a prefix sum, right? This is also a prefix sum. So we can just iterate through, if the cuts are the same size, then we don't have to redo it, right? So like this cut is the same, but these two cuts are the same. So we also keep track. So like we have a cut. So the first cut, we're actually going to put a 0 at the beginning, right? It's going to be a 0 at the beginning. So the first cut is going to be 1. Second cut, the horizontal wise, the height is also going to be 1. And we 1 already considered, so we don't consider it more. Now it's a 2. Now if it's a 2, isn't that the value going to be double? Yeah, because it's double, so it's double previous, right? That means we already know from just one of this, we already know the maximum, right? We know the width. We know the width, right? We know the width of each one, and we just need to pick the largest width, and we need to pick the largest height, right? The largest width and the largest height. So this is the same thing. So we just need to pick the largest width and the largest height. Now to find the largest width, we just have to run through the entire thing, and then I think we have it. Yeah, I think we have it. It's a cumulative sum, so we're going to say the start is 0, right? So just this minus 0, and then the end. Alright, I'm back, and let's do this. I think we can solve it in one shot. I have confidence. Okay. Alright. Let's copy this in. Okay, so we need to find the maximum. Oh, it's going to be the same function. The same code, you run it twice. So basically what we're saying is we're gonna horizontal cuts dot append, right? Horizontal cuts These are horizontal cuts, right? Dot append height, right? And then we say max height equals horizontal cuts 0. And then let's say for I in range 1, 2, then horizontal cuts max h equals max h horizontal cuts I minus horizontal cuts I minus 1. And then we're going to do the exact same thing with vertical cuts. So I'm going to do vertical cuts. The only difference is this is not going to be max h. This is going to be, oh shoot, this is going to be max w, right? Max w, and this is going to be w. And then max w is going to be 0, and then we're going to say it's going to be from 1, 1 minus 0, yeah, and then when return max h times max w, and we say we're going to mod 10 to the 7, 10 to the 7, 10 to the 9, plus 1, plus 7. I'm going to say, write it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to be 7, right? And we're going to write just a few test cases. First test case is 5, 4, 1, 2, 4, and 1, 3. This we shall have 4. Second test case, 5, 4, 3, 1, and 1, which gives us 6. Third test case is 5, 4, 3, and 3. This gives us 9. Right, and then we're going to change this to H, W, horizontal, vertical, then HW, horizontal, vertical, and then this one's going to be max area. Try it. Oh, we passed 2, we failed one of them. How is that possible? Horizontal cuts. Oh, it's not sorted. Alright, that is and they never say it's sorted. Ha! Why would you do that? Do we have to sort? Does that mean we have to sort? I is the distance from to the I. Yeah, I guess we have to sort. Okay, so what do? We do, man, oh man. Then that's not ON, that's ON log N. ON log N. I do not like this. But we have to sort. So this dot sort, and we have to do the same thing here. Vertical dot sort. They say the two is the same. Let's just write a function. I think It'll be easier. Let's just write a function. Let's say def find max, right? Find the max, and we're gonna say the end value and the list, right? End value and list. So now return a int. End value is going to be an int. List is going to be a list of int, and we just say the list right here. So we say list, and first sort, and then list can append, not h, it's going to be end value, and this is going to call it max value, max val, right? And then this one going to return max val. Okay, so when we do this, we can just say return find max, end value is height, and horizontal cuts times find max w vertical cuts, and do this. Yeah, it's the same. So I like this. This one's clearer. So I hope this one can pass just directly. Pending, judging. Yep, we got it. So yeah, our intuition was correct. The intuition is to find the largest height and the largest width in all the cuts, and their product is the solution. Since the given horizontal cuts and vertical cuts are prefix sums after they are sorted, it is trivial to find the length of each height and width, right? I'm thinking maybe there is a better way. Like we can use the we can use the zip method. Yeah, maybe we can. Yeah, I think there are smarter ways. So it's gonna be n log n, right? N log n plus m log m, right? Where n, m are length of horizontal cuts and vertical cuts respectively, and we run at a, what's our time? Oh, at 412 milliseconds. That's terrible. 5% ranking. Can you tell me that there is a better solution? I mean, I have the other idea, because I know looping usually is slow. So let's try my other idea. Maybe if we use zipping, it will be faster. So the zipping idea is that I think these are ON solutions. But how can you do ON solution when we don't even know if it's sorted? Like if it's not sorted, how can you do that? That's interesting. So let's just do horizontal cuts.sort, right? Vertical cuts.sort, and max h equals max h2 minus h1 in for h2 for h1 h2 in zip horizontal cuts 1, right? And for the same thing, that's going to be max width equals w2 minus w1 for w1 w2, and this is all going to be vertical cuts, right? And then we're going to return max max h and horizontal cuts 0. Yeah, horizontal cuts 0, and height minus horizontal cuts minus 1. So that's the actual thing. And we can combine these two together. Yeah, let's do this. So this can be here, max h, and we say max h equals this, right? And then we have the same here, max w equals max w, vertical cuts 0, and width minus vertical cuts minus 1, right? So I'm going to return max h times max w mod this. Okay, let's try 2. We fail. Much as not an empty sequence. Which one? This one. Ooh. Max is empty sequence. Okay. That's easy enough to solve. So we just need to append horizontal cuts dot append h and vertical dot append w. So these are done, and now it's actually make it easier. We don't even need these two. We just need to do this. It's going to be max this with horizontal cuts 0. With this one, we don't have any comparison. So the same thing, max this and vertical cuts 0, and we pass. Let's see if this one is faster. If this one is still not faster, then definitely we have probably an ON solution that we just don't know. I guess it's a like naive ON log n solution. Ending, judging, accept, probably still. Oh, look at this! Way faster. So this one using zip to speed things up. Same runtime, same complexity, but runtime shrinks to 304 milliseconds. 304 milliseconds, and with 71% runtime, just by changing this part. Okay, I'm pretty confident, pretty happy, so I'm going to look into the solution. This one probably don't have a solution. No, it does not. It's a medium, let's say medium rare. It's a medium easy question compared to yesterday. I mean, yesterday is also not hard. It's just I got royally stuck. But this one has 36%. I don't know. That's pretty straightforward to me. I don't think I've done this before. No. So that's also from a contest. So this contest will be, not contest, it's going to be LeetCode aside code. Alright, let's see, solution. Other people have other ideas? Do you like visual explanation? Uh-huh. You must think of length and breadth. Length and breadth. Length is total horizontal length. Height is the total vertical height. Each number of each cuts is an array of horizontal cuts. Find heights that we only perform horizontal cuts. Find the length pieces. Find the max. Multiply. Yeah. So yeah, you do have to sort. See, you do have to sort first. You find a horizontal. You find the vertical. You take the max, and then you output. Yeah. Okay, yeah, I think that's the 3 line. And the 3 line. Sorted. Fair enough. I don't want to do that because I think that's gonna affect the runtime. But no, it doesn't affect. This is OM, and you do sort. Yeah, it doesn't affect the runtime. And max times max. Yep. Okay, that's it. It's actually pretty straightforward, this one. All right, that's it for today. I will see you guys tomorrow. Adios.